welcome to my bench. If this is your first time, welcome. And if you've been here before, welcome back. I'm going to start a new series that I'm going to call QuickTakes. These are just going to be quick little 10, 12-minute videos on electronics in general, and probably mostly on parts. How they work, what they are, what they look like, sometimes what they look like inside. And today we're going to start with the poor little resistor. These are everywhere. And, they're the most used part in electronics. However, not all resistors are created equal. And specifically in this demonstration, as far as RF goes, I want to show you how they differ. What we have here is a wire wound 33 ohm resistor. Let's get the meter up, and I'll show you that it says 33R on it. I believe this is 5 watts, and it is 5%. And it says 33.1. That's pretty good. This is a carbon comp resistor, way old style, like you see in everything, older stuff. And it is quarter watt, I believe. And it is 32.438. And this is a carbon film resistor, the new style. And it is 32.6. So, they're all close enough for us to use in our little demonstration. Well, for this demonstration, I have a WaveTech sweep generator, RF sweep generator that goes from, a couple megs up to, 1.4 gigahertz. And I use it because it allows me to sweep manually with a knob. It's very, very handy. It works great if I want to do something slow. And my spectrum analyzer, which I'll bring up here right now and show you. Get rid of that and bring up the spectrum analyzer. All right. As you can see on the spectrum analyzer, we're looking at the frequencies between 2.5 megahertz and about 75 megahertz, a sweep time of 5 milliseconds, and a resolution bandwidth of about 1 megahertz, because it gives a nice peak that you can see. Our base not connected is about 170 dB, 166 dB down, okay? So what I'm going to do is I'm going to put together my leads. This lead here comes from the frequency generator, the sweep generator, and this lead goes to the spectrum analyzer. Now, they're garbage leads, so it's going to introduce some noise and crap and whatever, and some drop. So, but it's not important to what we're doing here. So let's put them together and bring this out a little bit. All right there. Oh, we can get rid of that. All right. So right there we've got, that's about 3.95 megahertz. Let's take it back just a little more and find the peak. There we are, 2.8 megahertz approximately. And when we turn the knob and sweep it across, you can see it drops some. It drops because of these leads that I've got, not the generator. It's pretty solid. And that peak is 73.5 down about 46. So we're talking, what was our, right there, we're about 40 dB down, 39 to 40. And because of garbage leads, down about 46. So about 6 dB drop overall, okay? Just the way it sits with the leads connected together. So let us take our old-fashioned carbon comp resistor here and put him in series with the spectrum analyzer and the sweep generator. We are going to drop a little bit in level because the resistor is resisting. It's doing what it's supposed to do. So now we're down about 41, 42, someplace around there at 2.86 megahertz. And what we want to do is we want to sweep across our entire frequency range from our 2.5 to 72. So let's start the sweep manually, and as you can see, it's staying pretty stable. We're up at about what are we at now? We're up about 28 megahertz. That looks good. And we're still 42, 43 dB down. It starts to drop a little like it did before, and we're about 44 at 49 to 50 megahertz, and at the top of our run we're 47. So we went from 40 to 47. So we got 7 dB drop with this resistor in here, which is identical, or darn near identical, to what we had before. So this resistor, this carbon comp resistor, is not doing anything as far as our circuit's concerned. All right, let's try the modern guy, the carbon film. Take it back to 0. Well, whatever it is here. And right there, we've got a peak about 41, 42, 41 and a half, somewhere around there, bouncing around. Don't pay any attention to all that garbage on the bottom. That's introduced because of noise in the building and all kinds of stuff. I mean, there's so much noise out there, you just wouldn't believe it. Anyway, so let's do our sweep now. Remember, we're starting about, 41 and a half. And we're doing good. We're up about 39. We're still at 44. So a couple dB, 3. And we'll take it up to the top here. And we're at 47. So identical. Same as the old carbon comp did. Great. All right, now let's try this guy. Take it back down to there. And hook him up here. And bring him out to where I can see him. There we go. And it's about 41, 42 dB at 3.5, 3.5 megahertz. So it's the same as the rest of these guys. All right, so let's start sweeping that across a little bit. And, oops, it's going down quickly. It's dropping like a rock. So when we get up, let's get up to 28 megahertz, someplace around there. Oh, I don't know. Remember, 28 megahertz or 30 megahertz, we're down 50. So we've already lost almost 10 dB. Just from over here, we're down 41, 42. And over here, we're down 52. So there's 10 dB loss between 2.5 and 52 or 35, 36. So let's take it on out to here. And since that peak is actually lower than my band noise, I'm going to have to put a marker on here and go find it. There we go. We are 61 dB down. That's 20 dB. So you're losing 20 dB of signal through that resistor right there. Well, there's a reason for that. This is a wire wound resistor. And basically, it's a form with a bunch of wire wrapped around it. Nichrome something, I don't know what they use in these actually, but there's a bunch of wire wrapped around it, and that wire wrapped around that form creates a inductor. This is an inductor doing what inductors do at frequency. So you can't use this kind of resistor as a pure resistive load. If you put this in a circuit to drop your RF from one point to another, it would definitely drop it, but that's not the way you want to do it. You want to do something else. If you want to use this as an external load, like a dummy load, if this was 50 ohms, you couldn't use it for that either, because it would present an SWR because of the inductance inside of this to your transmitter and throw the whole mess off. So resistors are not all created equal. I just thought I'd show you guys that in this little quick take, and hope that you learned something from these little guys. So if you're on YouTube, don't forget to give this a thumbs up and subscribe and ring the bell to see what I'm doing more of. However, I'm going to start doing a lot of these little quick takes and lessons, and they're only going to be on Patreon. I've opened up a Patreon page, and this will be the first one up on Patreon. AERV blog over on Patreon. So if you want to see the lessons, the basic lessons and the things that I do for this, they're going to be over there. And the other repairs and stuff will be up there too, but they will come over to here. So you can see the repairs first on Patreon, and some of the things will only be on Patreon. So, hey, thanks for watching. Don't forget to register, and we'll see you next time.